It's an organic chemistry question. So it says to draw the structure of a tetrahedral intermediate initially formed in the reaction shown. Then draw the structure of the acyl transfer products obtained. So we're going to react an acid chloride with an alcohol. So some other things to consider. So we do not have to think about stereochemistry. We do not need to include counterions. So to answer this question, I am going to open up a PowerPoint so that I can draw out the answer. Okay. So here is our acid chloride, which in this case is our electrophile. As well, this is our alcohol, which is our nucleophile. So the alcohol is going to undergo a nucleophilic attack onto our electrophile. So the way that's going to start is from the lone pairs on oxygen. These electrons are going to attack the carbonyl of the acid chloride. So right now, if we were to draw out the answer here, this carbon, the carbonyl carbon, would have 5 bonds, which can't happen. It can't have more than 4. So we're going to need to push the electrons from the carbonyl back into the oxygen. So drawing this out, we end up with this intermediate. So we pushed the electrons into the oxygen. So now it is negatively charged because it only has 1 bond instead of 2. And then we're adding on the alcohol, which is still protonated. We haven't gotten rid of that hydrogen atom yet. Okay. And then because this oxygen has 3 bonds, it is positively charged. So this is our tetrahedral intermediate because the carbonyl carbon is attached to 4 things. So that's why it is tetrahedral. To really highlight that this is the intermediate, you can draw really big brackets around it and then add this little symbol which shows that this is an intermediate. This is not something you could isolate. So from here, we could either, so we're going to collapse the tetrahedral intermediate to reform the carbonyl. So we could either kick out the alcohol, which then gives us the starting material again, which is unproductive, or we can kick out the chlorine, which is a very good leaving group, so it's pretty ready to leave. So taking the lone pair from this oxygen, pushing it down, and kicking out the chlorine will give us this product. So carbonyl is reformed. So now we have gone from an acid chloride to an ester. And this oxygen is still positively charged. So we're not quite done here. We need to get rid of this positive charge. So we need to deprotonate this oxygen. So in our last step, we released the chloride anion. So this will abstract the hydrogen from the oxygen. We're going to push the electrons back into the oxygen to get our final product. And we also formed HCl as a byproduct. And that is how you draw the mechanism for an acyl transfer reaction.